Hello, welcome back to the class. Today we're going to talk about contingency table. Contingency table displays frequencies for a combination of two variables. Okay, so we're using data from a statistic class. Data was connecting on whether students like chocolate and whether they like espresso. So in here, first of all, I want to teach you how to read the table. For example, 11. What does 11 means in here? So 11 means among the students we surveyed, 11 of them liked chocolate and espresso. Now, what about 1 mean? So 1 in here is the student, only one student out of 23 students who doesn't like chocolate or espresso. So now in the last column, in the last row, it says total. What does total mean? So total, such as the number 18. Let me use a purple one. 18 means the student who likes chocolate. They can either like espresso or that doesn't like espresso. It doesn't matter. These two numbers combined is the student who likes chocolate. So, and you need to be careful. The total in here, which is the student who like chocolate and who don't like chocolate, should be, when they add them together, should equal to the total number of students. And these two, when they add up, should also equal to the total number of students. Now, the marginal probability. What proportion of students who likes chocolate? I'm going to erase this one. Now, we want to know student who likes chocolate. So in this case, we don't care about whether they like espresso or not. They can like espresso or they don't like espresso. That's fine. So in this case, we want to know the total number of students who like chocolate, which is this column, right? So 11 of students, they like chocolate and they also like espresso. 7 students, they like chocolate, but they don't like espresso. So the total amount of students who like chocolate should be 18, and then out of the total number, 23. This is the student who likes chocolate over the total number of students. Okay, what proportion of the students who don't like espresso? So, students who don't like espresso should be this one, right? This row, including students who like chocolate and the student who doesn't like chocolate. So the total number of students who don't like espresso should be 8 out of 23, which is student who doesn't like espresso over the total number of students. Okay, so these are called marginal probability because we use the number in margins. They use the total for the single variable. Okay, so joint probability. So joint probability is the proportion that they overlap in. Now, let's take a look. For the same map, what proportion of class like espresso and chocolate? That means they have to satisfy both conditions. They like chocolate and espresso. So in our chart, only 11 students who satisfy both, because for 11, the number 11 says, hey, student likes chocolate and espresso. Because if you look at 7, 7 is student who likes chocolate, but they don't like espresso. So in this case, it's going to be 11 out of 23, which is the probability that students like espresso and the chocolate. Okay, what proportion of the class not like espresso and not like chocolate? So now we need to find out which part. So okay, so now let's look back. Which part that student who doesn't like espresso and the chocolate? So for student who doesn't like chocolate, we have this row, and they also doesn't like espresso. It's going to be 1. So that means 1 out of 23 students, they don't like espresso and they don't like chocolate. That is the overlap part. So these are called joint probability because they're intersection with 2 variables and they are the probability. Okay, so conditional probability. What is conditional probability? So what of the proportion that students like chocolate also like espresso? This is a conditional probability. So conditional probability is the possibility of an event or outcome happening based on the existence of previous events or outcome. So now take a look. The student who likes chocolate also like espresso. So the existent condition, the existent event or existent outcome is going to be given student who like chocolate, and we want to know among those students who like chocolate who also like espresso. So now let's take a look. Go back here. Student who likes chocolate, I'm going to erase all of that notes. Student who likes chocolate is going to be in the first column. And then out of these, who also likes chocolate, so it's going to be 11. So that means we want to know this is going to be student who likes espresso. Oh, I spelled it wrong. I spelled it right. Sorry. Who likes espresso and the chocolate out of student who likes chocolate. It's not the total amount of student, it's out of the student who likes chocolate. So this is going to be 11 students, they like espresso and chocolate out of the total number of students who likes chocolate, which is 18. So this is called conditional probability. Next time we will talk more about what is and how to calculate conditional probability.